Hey guys, welcome to your second video of the third chapter. This is all on unit conversion. So last video we focused on SI units and the unit conversion table that I've given you. We are now going to take that a step further and learn to convert between different units. And you have already practiced this in class, so hopefully it doesn't seem super overwhelming. This is a little bit of a different concept. We're going to be talking about some different ways on how to do this. So if you feel very overwhelmed, don't worry, we are going to practice in class. Before you ever get a quiz or a test on this information, you will have practiced quite a bit. So here are the things that I'd like you to know when you are done watching this video. You should be able to identify and use conversion factors. You should be able to use dimensional analysis to convert between units. And then you should be able to perform derived units calculations. That third objective, we're probably just going to take out for this video. We may not focus on that right now. We'll focus on that in the future. I really want to just make sure I know where you guys are at before I make something even harder. So a couple of things before I start talking about what's on the slide here. A couple of questions I want you to ask is, why are units required when reporting the results of a measured quantity? And remember when we talked about in other videos, if I just said 15, well, what am I referring to when I'm looking at a table and I say 15? Am I referring to the height, 15, or am I referring to the weight? Am I referring to the length? We just don't know. So we put units to things to help give you more of an understanding when it comes to those numbers. If I were to say I have 4 cups of something, well, that's easily, if I have 4 cups of something, that can be broken down into different types of factors. So 4 cups also equals 2 pints, which also equals 1 quart, which also equals 0.25 of a gallon. So there are different ways to express the same amount of something. So it can be really confusing. That is why in science we use the metric system. And the reason why we use this is because the metric system uses powers of 10 for all conversions. So it's actually quite easy to convert between centimeters and millimeters in comparison to converting from 4 cups to gallons, because the numbers aren't in numbers of 10. They're just completely different numerical values, still equal the same amount of something, but completely different numerical values. Conversion factor is a ratio of equivalent measurements. So like I said, 4 cups equals 2 pints, which equals 1 quart, which equals 0.25 gallons. When you convert those things, you're going to use a conversion factor. Those all have the same amount of something, but different ways to represent it. Another way I represented this here is I used 1 meter equals 1,000 millimeters. They're the same amount of something, but it's using 2 different units to express that same amount. So again, using the meter system is just so much easier because you're in numbers of 10. So I already used here 1 meter equals 1,000 millimeters. I could even break this down and say 1 meter equals 10 decimeters, which equals 100 centimeters, which equals 1,000 millimeters. Yes, all the numbers are different, but it's still the same value. And I can show you this on a meter stick in class so that hopefully you guys are kind of see where I'm coming from. All right, so this is the slide that I'm assuming a lot of you are going to be like, whoa, hold on, let's take a minute and break this down. This is a really extreme concept, dimensional analysis. Some of you may find that it's really easy. Maybe you've done it before, and some of you are going to be very overwhelmed. It is okay. We're going to spend a lot of time doing this. Honestly, dimensional analysis is exactly how I passed physics. So if you can figure out your units and what units you're looking for, you can eventually get to your answer. And that's basically what dimensional analysis is. So the more technical term is a technique that uses the units of the measurement in order to correctly solve problems. And so I'm going to show you this technique and I'm going to walk through this. We have an example here. So I am going to do this one with you. And then on the next slide, there is a more, more chemistry-based problem. So that you can see this in a number of different ways. So my question to you is, how many seconds are in a day? So you may already know this, but not many people know this off the top of their head. So there are a few steps on how to solve things using dimensional analysis. The first step is to list the known quantities and the plan for the problem. I really did some typos here. Or and plan the problem. So that's step one. So the very first thing I want you to think about is, what are you going from? You're going from days to seconds, right? Because you want to know how many seconds are in that day. So you're going from a day to seconds. So let's list. One day equals what? How can we break that up? So we can say one day equals 24 hours, right? I've broken it up even further. Same amount of same value, just different numbers to represent that. Now I can break down 24 hours. I can say 24 hours, 1 hour, not 24 hours. I can break that down even further. So 1 hour equals 60 minutes. Okay, and then I can break down minutes even further. I can say 1 minute equals 60 seconds. I'm going to put an S. All right, and so now it takes me to, I've gotten from day to seconds. Now I need to do a conversion. Okay, so my unknown here is 1 day equals how many seconds? How you set up a conversion factor, and I'm going to erase this so that I have some room. How you set up a conversion factor. So again, I had my known quantities, and I also have them on my paper, so I know that I erased them just for the sake of room, but I do have them written down on my paper. You should always write down every single number that is given to you when you are trying to convert, because I promise every number is important. I will never give you a problem where you're never not using a number. So every single number when you are converting is important. So just remember that. All right, let me get my pen back. All right, so 1 day equals 24 hours, 1 hour equals 60 minutes, 1 minute equals 60 seconds. So I'm going to set this up starting at days. So remember, I have 1 day. How you do your conversion factors is you basically set up like a fraction format. And remember, how many hours are in a day? 24. How you want to eliminate or convert between different units is try to get rid of those units. So 1 day times 24 hours, that would leave me at day times hour for my unit. So at the bottom or in my numerator, I need to have the same unit as my denominator and numerator units need to be the same so I can cancel them out. Because this is like saying 1 day over 1. Okay, so these two, this is at the top, this is at the bottom. Anytime you see two of the same units at the top and bottom, they cancel out. So far I have 1 times 24, but my days canceled out, so I'm left in hours. Now I don't want to be in hours, I want to be in seconds. So then I go from 24 hours, how many minutes are in hours? So I'm going to again multiply 60 minutes. How can I get it to where I cancel out my hours? I'm going to put 1 hour at the bottom. Those two cancel. Now I'm left in minutes. Okay. Now I'm not to where I want to be, so 60 minutes. So then I'm going to multiply 60 seconds, divide that by my 1 minute, and I should have 86,400 seconds. So that means if I multiply 24 times 60, I should get 86,400. Everything canceled out and it left you in seconds. I'm sorry I didn't write that here at the bottom. I don't have very much room. 86,400 seconds. So look, all I did was go through, and on the top and the bottom, I had the same units so that I could cancel things out. That is all you're doing in dimensional analysis. You're canceling units out until you get to the unit you want to get at. And I know it sounds so easy to say, but as you practice these things, they just become easier and easier. I have like 10 to 15 years of experience doing this, so I'm going to walk through this really slow so that you're understanding what I'm talking about, because this can be so overwhelming, and your problems and your answers won't be right if you're not in the right conversion. Okay, so that's really important, because you can miss a whole bunch of points because you didn't convert something from meters to kilograms, or meters to kilometers, or from grams to kilograms. So that's really important to look at. And anytime somebody gives you a problem, you always got to look at the units that they're asking for. So here's another problem that I wanted to use, and I'm using the metric system now. So a particular experiment requires 120 milliliters of a solution. The the teacher knows that he will need to make enough solution for 40 experiments to be performed throughout the day. How many liters of solution should he prepare? So the first thing I want you to know is that I gave you your units in milliliters. You are going from milliliters to liters. Okay, so you're going to need your conversion table to help look at how many times you are moving your decimal, how many times you're going to be either adding a zero or taking away a zero. Okay, but don't worry, we will practice that in class. When you look at your table, it makes more sense. I don't have a table on this, so it's really hard to visualize. But the first thing I want you to write down are the things that you know. Okay, so you know that one experiment requires 120 milliliters of solution. I'm going to put SOL. Anyway, 120 milliliters of solution. Okay, and the next thing that I don't expect you to have memorized, but on your conversion table, it shows that 1 liter equals 1,000 milliliters. Okay? So since each experiment requires 120 milliliters of solution, that means the teacher needs to prepare enough for 40 experiments. You can multiply 120 by 40 to get 4,800 milliliters. Okay, so already you are at an advantage because you know that 120 times 40 equals 4,800. That is not good that the announcements are going off. But remember, the question asks you how many liters of solution should he prepare. So you know that you need 4,800 milliliters. Now we need to convert that milliliters to liters. So again, you're just going to do your dimensional analysis. Okay, so how can I cancel out my milliliters? Obviously, I need to have something at the bottom because this is at the top. Remember, this is like saying 4,800 over 1. Okay, so down at the bottom, I should have milliliters so that those two cancel. But I need to have the correct numbers. So it would be 1 liter, because I remember I already told you 1 liter equals 1,000 milliliters. So 1 liter over 1,000. And that gets you 4.8 liters. So you need 4.8 liters to do the 40 experiments. Okay? If you have any questions, ask me on Edpuzzle.